Okay, how much heat does it take to do this or that or the other thing? That's what this video is going to be about. So the amount of heat. Heat is a type of energy, and therefore it is measured in joules. So how much heat does it take to heat something? Well, part of that is the word something. So we've got to have some mass. So that means we're going to have an m in the equation. And if we're going to heat it, that means we're going to change the temperature. So that means we've got to have temperature in it. And we've actually got to have two temperatures. We've got to have a final temperature and an original temperature. So we're going to have TF and we're going to have TO. So we've got, what do we got so far? We've got joules, we got energy, we got mass, we got TF, we got TO. There's one more thing. Each substance is different. Some substances are easy to heat, some substances are hard to heat. So we need a constant that is different depending on the different substance. So really quickly, I'm going to go out and surf for an image. I'll be right back. Okay, I'm back. We were talking about a constant that depends on what you're heating. That's called, excuse me, it's called the specific heat. I don't know who named it, but I don't know if they did a good job. But specific heat is a number that depends, or that depends on what material you're heating up. So I went out and I found this picture, or this image, and you can see like liquid water has a specific heat of 4.18 joules per gram degrees Celsius. So that's it's just a number that tells you how easy or how hard it is, how many joules of energy it takes to heat up a gram of water a degree Celsius. So look at these numbers, check them out. What are the biggest numbers on here? Well, the biggest number on here is liquid water. So liquid water is very hard to heat and hard to cool, by the way. What's pretty darn easy to heat and cool? Things like lead, metals. Look at how low these numbers are on these metals down here. So water, very hard to heat or cool, and metals, very easy to heat or cool. I could do a whole video on that, but I'll spare that. I'll spare you from that right now. Okay, I'll move that out of the way. And when we put all these things together, the amount of heat equation is the energy, the heat energy, that's Q, equals the mass times the specific heat times the change in temperature. So we got mass is there, the constant specific heat is right there, and then the change in temperature is right there. And then joules, the energy, that's the Q. Once again, who came up with the Q? I have no idea, but we're stuck with it. So Q is heat. Now, if you don't like this delta T thing, you can simplify that a little bit. Q equals MC, and delta T is the change in temperature. So it's actually temperature final minus temperature original. That should look kind of familiar to you because earlier in the year we had what? Acceleration was change in velocity over time. So we had VF minus VO. So anyway, here it is. That is the equation that solves for how much heat it takes to do something. So let's just say that you've got a mass of, I don't know, 400 grams, and we're talking about a material, let's say we're talking about iron, and let's say it has an original temperature of 30 degrees Celsius, and we want to heat it up to a final temperature of 110 degrees Celsius. So how much heat would that take? How much heat would it take to do that? All we've got to do is just take these numbers and fill them into this equation and then solve it for Q. Pretty easy stuff. So let's see here. Q equals M, so that's going to be 400 grams. And then the C is for iron. So right here, it's 0.45 joules per gram per degree Celsius. So that's 0.45 times our change in temperature. So if you're the mathy type, you can just go 110 minus 30. What is that? 110, 190, 80. That's 80 degrees. Or you could write it out. 110 minus 30. So you go, okay, yeah, that's 80. All right, so basically, on a calculator, all I have to do is go 400 times 0.45 times 80, and I get 14,400, 14400. Okay, so 14400, and that is joules. So that's how much heat. It takes this many joules of heat to heat 400 grams of iron from 30 degrees up to 110 degrees. So that's it. This equation, all you got to do is, when I give you a problem, I'm going to give you a number of things. I'm going to give you that, or that, or that, or maybe these two, and you've just got to find what I don't give you. So that means, yes, you're going to have to do a little bit of algebra, perhaps. So when I say you have to do a little bit of algebra, I mean, what if I gave you the heat and the C and the TF and the TO, and you had to figure out M? You know, how would you do that? Well, if M is multiplied by all this other stuff, you just have to divide by all that other stuff. So M is going to equal Q over C times delta T, or instead of delta T, you could have TF minus TO. But at this point in your career, I expect you guys already know how to mess with the equations pretty easy like this. So that's it. That is the amount of heat equation.